Lesson 21 is solving quadratic equations by factoring. So in 21.1, we have to start off by introducing something called the zero product property. So that's up in the top left corner. So zero product property, if P and Q are real numbers and P times Q is equal to 0, then either P is equal to 0 or Q is equal to 0. So that's a property that just helps us solve factored equations. So if we look at example 1, this is an example of a factored equation. Meaning that we don't have to use factor by grouping or anything like that. It's already in factored form, which is when you have different kind of, factors, for lack of better terms, are multiplied by each other. So like 3 times x minus 5 times x plus 1. These are three different factors. The 3, the x minus 5 is a factor, the x plus 1 is a factor. And then, of course, factors are just things that are being multiplied together to get a final product. So in example 1, solve for x. So it's 3 times x minus 5 times x plus 1 equals 0. So the zero product property says that if these factors multiplied together equals 0, then I can just set each factor equal to 0 to solve for x. So it's really, really important that for the zero product property, you have a 0 on the other side of the equal sign. It does not work with any other number. There has to be a 0. But we have a 0 there, so we're good. So we're going to set each factor equal to 0. If you want, you can take the 3 and set that equal to 0, but it doesn't involve an x, and that's not a true statement, so it's not really relevant. So the next factor we would set equal to 0 would be x minus 5. So I take x minus 5, and I set that equal to 0. And then I'm going to take the third factor, x plus 1, and I'm going to set that equal to 0. And then now what I did is I just kind of created two equations. I have an x minus 5 equals 0 and an x plus 1 equals 0. And my goal is to solve for x. That means I get x by itself in both of those. And we just treat them like two completely separate equations. They're not going to like overlap with each other at all. So for the first one, x minus 5 equals 0. If I want to get x by itself, that 5 is being subtracted from x. So to undo subtracting 5, I would add 5. And then whatever I do to the left side of the equal sign, I have to do to the right. So I would bring down an x, and then negative 5 plus 5 is 0. That cancels out. Bring down the equal sign, and then 0 plus 5 is 5. So that's one of our solutions. And then the second equation, the x plus 1, that 1 is being added to x. So in order to undo adding 1, I would subtract 1. And then, of course, I have to do it to the other side of the equal sign as well. So from there, I would bring down my x, and then 1 minus 1 cancels out, that is 0, bring down the equal sign, and then 0 minus 1 right here is negative 1. So I end up with x equals negative 1, and then that's it. Solve for x just means we got to get x by itself, and we've done that. So our solutions are x equals 5 and x equals negative 1. Okay, so example 2 says find the zeros of the quadratic equation, which those directions are different, but our final outcome or our goal for this problem is the same. So find the zeros means that whenever or wherever the y is in the function, or sorry, in the equation, you'll replace that y with 0, and you'll just rewrite the equation that way. So we're going to replace that y with 0. So that's always the first step. Like when you see find the zeros, you just take y out and you put a 0 there instead. So we have 0 equals 4x squared plus 10x minus 6. So the reason that we do that is because zeros is like kind of a special term in algebra. It's not really referring specifically to the number. Zeros mean like where the value of our, it's called a function. We haven't talked about them too much yet, but it's where the value of the function is equal to 0. So that's why we make the value of y equals 0. And then we'll solve for x from there. We talk way more about functions like later on in the year. So they just kind of had it thrown in here a little bit. So I wanted to get that vocab going. Okay, so our new equation is 0 equals 4x squared plus 10x minus 6. And then this is not in factored form. I'm actually going to zoom back out really quick. So example 1, that equation was in factored form because we had our different factors, like the things in parentheses, being multiplied together. We don't have that here, so we have to factor. Okay, so when we factor, the first thing we do is we always check for GCF, greatest common factor. So between 4, 10, and 6, they all have a common factor of 2. So I can factor out a 2. And then the first two terms have an x, but the 6 does not have an x, so I can't factor out an x. And then now I'm going to take that 2 and I'm going to kind of like undistribute it or divide it out of each term. So if I do 4x squared divided by 2, it'd be 2x squared right here. And then 10x divided by 2 would go right here. So 10x divided by 2 would be 5x. And then negative 6 divided by 2 would be negative 3. Okay, so when we have a GCF that is just a constant, so like a number without a variable 2, we can technically divide it out of the equation if you would like. It's not like you don't have to. So instead of like factoring out a 2, I could have just divided the entire equation by a 2 and it would have kind of disappeared. I don't always like to do that though, because then sometimes we want to do that when we have an expression where there's no equal sign. We can only use that strategy if we have an equal sign, if it's a true equation. So I think it's better to be safe than sorry and just kind of leave it in front like that. Okay, so we have the 2 factored out, and you can always check to see if you factored out correctly by like kind of distributing back in your head. So in order to do that, it'd be 2 times 2x squared is 4x squared. 2 times 5x is 10x. 2 times negative 3 is negative 6. And then now that I've factored out the GCF, I want to take that trinomial, those 3 terms that are inside the parentheses, I need to factor them. So since there's 3 terms and the lead coefficient is a number other than 1, I'm going to use that decomposition method that's from lesson 20. So the decomposition method says that we have to take A times C. So remember when I say A times C, I'm referring to standard form of a quadratic, which is ax squared plus bx plus c. So in this case, A would be 2 and C would be negative 3. B would be the coefficient of x is 5. So A is always the number in front of x squared, B is always the number in front of x, and C is always the constant. So first we take A times C. So that would be 2 times negative 3, which is negative 6. And then we'll jot down what B is. B is 5. So the decomposition method requires us to break down this middle term. In order to figure out what we break it down to, we need to find numbers that multiply to A times C. So in this case, they multiply to negative 6. And they add up to B, so they add up to 5 in this case. So for numbers that multiply to 6, and you don't have to worry about the negative quite yet, we'll just list the factors of 6. So 6 is 1 times 6 and 2 times 3. So it can be really tempting to pick, okay, so we know we have to add it up to 5. It can be really tempting to pick 2 times 3. But we need our factors to multiply to negative 6. So that would mean that one number would have to be negative. So I can use like negative 1 and positive 6, 1 and negative 6, negative 2 and positive 3, or 2 and negative 3. But one of the numbers would have to be negative to multiply to negative 6. So now, like if I pick this combo, negative 2 plus 3 is a positive 1. It doesn't add up to 5. And 2 plus negative 3 is a negative 1. That doesn't add up to 5 either. So the correct combination that adds up to 5 would actually be negative 1 and positive 6. So negative 1 times 6 is negative 6, and negative 1 plus 6 is 5. Okay, so now we'll take those two numbers. I'm going to rewrite the rest of the equation. So it'll be 0 equals 2, and then parentheses. So the first part stays exactly the same, 2x squared. And then what we're going to do is we're going to take this 5x, and that's where the decomposition part comes in, is we're going to break it down into these numbers in front of x. So those numbers will be our new coefficients of x. It doesn't matter the order that we put them in. So I'm going to do a minus 1x, and you can leave the 1 off if you want to, plus 6x. So I took this combo that I found that, multiplied to a times c, added up to b like we said, and those became my new coefficients of x. And then I'm going to copy down this last little minus 3 at the end. But it's really important to realize that from right here, 5x, to the numbers that are replacing it, negative 1x plus 6x, that has the same value. So I'm not actually changing any of the values in the equation. I'm just kind of replacing 5 with negative 1 plus 6, which overall it's the same. Okay, so now that we've done that, inside the parentheses we have 4 terms now, so now we get to use factor by grouping. So to do that, we'll split the part inside the parentheses in half. So I'm going to do 0 is equal to 2, and then I'm going to add a bracket here just because I'll end up with a double parentheses. And then from the first half inside the parentheses, I want to factor out my GCF out of those two. So for the coefficients, 2 and 1, the GCF is just 1. That's the biggest number that divides into both. And then they both have an x. So x squared and x to the first power, I can pull out the lower of those two. So I can factor out an x as my GCF. And then I'm going to have 2 things left over inside the parentheses because I had 2 things up here. And then we can think in terms of dividing or multiplication to figure out what we have left. So if we think in terms of multiplication, I think, okay, x times what? X times something would have to go right here to bring me back to 2x squared. I would have to multiply x by a 2 and another x to go up to x squared. And then for the second part, x times something would go right here that would bring me back to negative 1x. I would just have to multiply it by negative 1 because x times negative 1 would be negative 1x. Okay, and then we repeat that process, but with the second half of the expression. So with this 6x and negative 3. So between 6 and 3, the GCF is 3. So we'll do plus 3. And then the 3 doesn't have an x over here, so I can't factor an x out. So when I try to figure out what is going to be left inside the parentheses, I can think 3 times what would go right here. That would bring me back to 6x. I would have to multiply 3 by 2x. And then 3 times what would go right here. To bring me back to negative 3, I would have to multiply 3 by negative 1 to bring me back to negative 3. And then this next step is important. Remember, you need to double check to make sure that these two are exactly the same. I forgot to put my bracket at the end. I'm going to add that in. But what we have in these two parentheses is exactly the same. So remember, if they're not the same, we have to kind of go back and try to find a mistake. But they are, so we're good. We can move forward. So this is in here one big term, and this is another big term. So our next step would be to copy down the 0 and then the equals 2 part. And then each of those two big terms, the ones that I've kind of highlighted in or underlined in blue, they each have a common factor of 2x minus 1. So I'm going to take that 2x minus 1 out of both of those. And then what is left over becomes its own kind of binomial in the parentheses. So x plus 3. So parentheses, I have an x and a plus 3 left over. And then now, we're not quite done with the problem yet, but now this problem is in factored form. So now I can set the factors equal to 0 to solve for x, because that's my ultimate goal with this problem. So this is, one factor is the 2, but I don't have to set it equal to 0 if it doesn't involve an x, because it's not going to give me a solution like what x would equal. So you can write, like I said, you can write 2 equals 0 and then just kind of cross it off because it's not true. One thing I want to add is on this problem, the 0 was on the left side. It's totally okay. It works the same exact way as example 1. So the next factor is 2x minus 1. So I can take that 2x minus 1 and set that equal to 0. And it can go on the left or the right side, the 0 part. And then the last factor is the x plus 3. So I can set that equal to 0. And then now we want to solve each one for x. So I'm going to start with the 2x minus 1 equals 0. So my goal is to get x by itself. This one has two things being done to it. There's a 2 that's being multiplied by it and a 1 that's being subtracted. So we'll undo the minus 1 first by adding 1 to both sides. So I would bring down my 2x. Negative 1 plus 1 is 0. That cancels out. 0 plus 1 is 1. And then my ultimate goal is to get x completely alone, and right now the 2 is being multiplied by it. So to undo multiplication, I would divide both sides by 2. 2 divided by 2 cancels out, so I'm just left with x, and then equals, and then 1 divided by 2, we can't really divide 1 by 2. I mean, we can, it'll give us a decimal, but we could also just leave it as a fraction. So we could write our final answer as x equals 1/2. Okay, and then for the last kind of equation that we have set up, x plus 3 equals 0. If we want to get x by itself, I just have to cancel out that 3 that's being added to it. So to cancel out adding 3, I would subtract 3 from both sides. 3 minus 3 is 0. That cancels out. I bring down the x, bring down the equal sign, and then 0 minus 3 is negative 3. So I end up with x equals 1/2 and x equals negative 3. I'm just going to write them over here so they're not quite as smushed. So x equals 1/2 and x equals negative 3 as our final answer. Okay, so 22.1 is solving by factoring in context, which usually means we have real world type of problems, which means word problems, basically. So there's only 2 examples here. They are going to be a little bit on the longer side, so just kind of bear with me. So example 1, there are 3 consecutive multiples of 5 that satisfy the following relationship. So multiples of 5, actually I'll start from the beginning. So I mean 3 is 3 numbers, but consecutive means like numbers in a row. So like 1, 2, 3. Those are consecutive numbers. Multiples of 5 would mean like 5, 15, 20, 25, and so on. So like an example of 3 consecutive multiples of 5 could be, say, 30, 35, 40. Those are 3 multiples of 5 that all come after each other. Or it could be 5, 10, 15. It could even be like 105, 110, 115. So any number that ends in a 0 or a 5 is a multiple of 5. So as long as we have 3 of those in a row, that would be 3 multiples of 5. Okay, so there's 3 consecutive multiples of 5 that satisfy the following relationship. The product of the first number and 33 less than the third number is equal to 20 more than the second number. I don't know why I underlined that. It ended up being the same exact thing. But we're asked to solve for not the same exact thing. It ended up being the whole line. So we're asked to solve for the first number. So that means that when we define our variable, we need to make our variable represent the first number. So we'll use x. So x is equal to the first number. And then we don't have to pick a different variable for the second number. We can write it in terms of x. So if you notice, like if you look at all of my first numbers and my examples of 3 consecutive multiples of 5, look at how we go from the first number to the second number each time. So 105 to 110, 5 to 10, 30 to 35. We're adding 5 each time to get to the second number. So our second number will be x, the first number, plus 5. So x plus 5 is our second number. And then we can approach writing the variable for our third number the same way. So we're still writing in terms of x, which is the first number. So we would still need to start with our first number in each one. But how do we go from the first number to the third number? So I go from 105 to 115, 5 to 15, 30 to 40. To go from the first number to the third number each time, I'm adding 10. So 105 to 115, 5 to 15, 30 to 40. So to write the third number, I would write it as x plus 10. The first number, x plus 10, equals the third number. And then now that we have our variables, we can go ahead and start to write our equation. So we're going to kind of break it up into two halves. So the first half says the product of the first number and 33 less than the third number. And then right here it says is equal to, so that's going to be our equal sign in the middle, 20 more than the second number. Okay, so product, that's like a key word here. Product means to multiply. So product is to multiply. So if we multiply the first number, which the first number is x, and then 33 less than the third number. So 33 less than the third number would be the third number, which is x plus 10. So x plus 10 is the third number, but it says 33 less than the third number, so I'd have to take the third number and subtract 33. Okay, so those are like all the words written out in our kind of variables. I'll go through that one more time really quick. So it says the product, which means we're going to multiply the, product, which means we're going to multiply the first number, which is x. And so x times 33 less than the third number. So just the third number is x plus 10. We wrote that right here, but it's 33 less than that, so we had to subtract 33 from it. So that's going to be all on the like left side of the equal sign, because it's on the left side of where it says or is equal to. So products, we'll take the first number, x, and we'll multiply it. So I'm going to put the second part in parentheses since we're multiplying. And then inside the parentheses will be this 33 less than the third number. So x plus 10 minus 33. And if you want to simplify like the 10 minus 33 before actually putting it into the equation, that's totally fine as well. So this represents the first number times, or the product of the first number and 33 less than the third number, which was this. Okay, so I'm going to erase some of this clutter. That's like the first half of the equation. That's everything to the left or in the sentence that came before is equal to. And then now we have the equal sign. So on the right side of that will be what comes after is equal to, which that is this like 20 more than the second number. So if it's 20 more, then that means that we have to add 20 to the second number. So more than would be add. The second number was x plus 5. So to get the right side of the equation, we have to take the second number, x plus 5, and we have to do 20 more than that. So we're going to have to add 20 to that to make it 20 more. Okay, so let me erase some of this. So So for the right side of the equal sign after where it says is equal to in the sentence, it's 20 more than the second number. So we take the second number, which is x plus 5, and add 20. Okay, so now we have our equation. So we don't have to deal with the words anymore, which is sometimes the worst part. So we're going to work on simplifying our equation. So in the parentheses over here, I have some like terms that I can subtract. So I have x, and then the parentheses, x plus 10 minus 33 is negative 23. And then bring down my equal sign. And then over here, I can add the constants 5 and 20. I have to bring down the x first, and then 5 plus 20 is 25. Ultimately, our goal is going to be to get the equation in standard form. You always want the equation in standard form when you're solving by factoring, which is ax squared plus bx plus c equals 0. So everything is on one side eventually, and it's equal to 0. Before we can do that, we have to go ahead and distribute this x. So we'll do x times x. X times x is x squared. X times negative 23 is negative 23x. And then bring down the equal sign, the x plus 25. So if I have to get everything on one side, I'm going to have to use inverse operations to cancel out some of this stuff. It's much easier if we keep the x squared term, like the lead coefficient and the lead term, positive. So I'm going to first subtract this x over. I'm going to take these two and I'm going to cancel those out on the right to move them over on the left because I don't want to have to subtract x squared because I would like to keep it positive. So I'll subtract x from here, and then I also have to subtract it from the other side of the equal sign. There's another term with an x there, so I'm going to line it up because those both have the same variable with the same exponent, so they're like terms. So I would do x squared, and then this is a negative 23x minus 1x. So if I start at negative 23 and I go down one more, it would bring me to negative 24x. And then the equal sign, and x minus x cancels out, which is what we were trying to do. So this is 0. And then I need to bring down my 25. And then I still need to get everything on one side of the equal sign and need to have a 0 on the other side. So next I'll have to cancel out this positive 25. So to do that, I would subtract 25 from both sides. I don't have any like terms with the 25 over here, so I'm not going to actually subtract it from those. I'm just going to put a minus 25 at the end of them, and then we'll write them all in a line. So it would be x squared, and then minus 24x, and then the minus 25 after that, and then the equal sign, and then from right here, 25 minus 25 is 0. Okay, so I couldn't like subtract the 25 from the negative 24 or the x squared because they were not like terms since the 25 had no variable. Okay, I'm just going to take this, now that it's in standard form, and I'm going to rewrite it over here on the right side just so I have a little bit more space to work with. So x squared minus 24x minus 25 is equal to 0. So we have our x squared first, x is second, constant third, and then is equal to 0. So now it's in standard form. So now we can go ahead and factor it. So the lead coefficient a is 1. So remember this is a, and then b is negative 24. That's the coefficient of x. C is the constant. So when the lead coefficient a is 1, we don't have to use the decomposition method. This was the one that kind of had the shortcut, and that was from 20.2 if you wanted to go back and watch that part of the video. 20.2 or 20.3, if there is 20.3. Okay, so our kind of shortcut is when we factor a trinomial, that's 3 terms, like 1, 2, 3 terms. It's going to break down into 2 binomials. So we're going to set up our 2 parentheses and then equal to 0. And then because this is just a 1x squared, it has to break down into x and x. There's no other possible combination. And then the way that we figure out what goes in the rest of the parentheses is we need to find c. So c is negative 25. Let's see. Trying to make sure I have enough space up here. I don't want it to get too cluttered. Okay, so c is negative 25. B is negative 24. The way that we figure out what fills in the rest of the space is I need numbers that multiply to C and add up to B. So multiply to 25, multiply to negative 25 and add up to negative 24. When you see kind of two numbers that are just one off from each other, more than likely the factors that you'll need that multiply to 25 will just be 1 and 25. So if we need them to multiply to negative 25, then one of these numbers has to be negative. If I want them to add up to negative 24, I have to make the 25 negative. So our combination that multiplies to negative 25 and adds up to negative 24 will be 1 and negative 25. That kind of looks like a semicolon. I'm going to fix that. So 1 and negative 25 is what fills in the remaining part of our parentheses. So this would be a plus 1 and a minus 25. And then now it's factored completely, so I can set each factor equal to 0. Okay, so x plus 1, that's one factor. I'll do x plus 1 equals 0. And then x minus 25, that's another factor. I'll set that equal to 0. And then now we just set each equation, we solve each equation separately for x. So I'll start with this one. X plus 1 equals 0. I have a 1 that's being added to x, so to cancel that out, I would have to subtract 1 from both sides. Bring down my x, 1 minus 1 cancels out. Bring down the equal sign, and then 0 minus 1 is negative 1. So that's one solution, x equals negative 1. And then the second solution is the second equation is x minus 25 is equal to 0. So in order to cancel out subtracting 25 from x, I'll have to add 25 to both sides. I'll bring down the x, and then negative 25 plus 25 is 0. I bring down the equal sign, and then 0 plus 25 is 25. Okay, so we end up with x equals negative 1 and x equals 25. Those are the correct answers. However, there is some context to this problem, so before we're like totally finished with this problem, we just have to think about what it was asking and what it stated at the beginning. So at the very beginning, it's a long problem. At the very beginning, it said there are 3 consecutive multiples of 5. And we were asked to find the first number, which is x. So we just found 2 numbers for x. We have to decide which one of those is actually the number that this problem is looking for. Well, only one of our answers is a multiple of 5. Negative 1 is not a multiple of 5. So by default, x equals 25 would be our main solution, our answer for this problem. And then x equals negative 1, it's still like a correct answer. We didn't do any work wrong to get that. It's just called an extraneous solution. I'll write that word underneath it after. An extraneous solution, those happen a lot with word problems where you get 2 answers but only one can make sense. So x equals 25 is our main answer. X equals negative 1 is extraneous. Okay, so I'm gonna stop the video there just because that was a really long example, and then I'll put up example 2 as just kind of an extra example in a separate video.